Citibank had commissioned a 53-story, 1.3 million square foot building to be built in 1977 in downtown Manhattan. The architect, William Lemichaux, created one of the most unique buildings on the Manhattan skyline, a building that was raised on 114-foot stilts and with a 45-degree angle at the top. There were multiple reasons as to why this unique building shape was chosen. Lemichaux had created the rough design of the building on a napkin while dining out at a Greek restaurant. When Citibank was buying land for their project, they had to make multiple purchases with multiple landowners. One of the purchases was with St. Peter's Evangelical Lutheran Church, located at the corner of the entire lot, which had only agreed to the sale for the land if Citibank demolished the old church and built a new church at the same site. Citibank agreed to these conditions and commissioned the architects to work around this new land constraint. Lemichaux proposed high-rising stilts at the midpoint of each corner to raise the structure off the ground and over the church. These stilts would have an inverted chevron shape to support the loads caused by the winds. Inadvertently, what they had done was created a comparatively much lighter base of a skyscraper because of the amount of material that was used. The chevron stilts had caused the structure to move considerably in the wind. To compensate for this rocking motion, Lemichaux had included a large concrete counterbalance called a mass damper at the top of the building. This mass damper would not properly work in the event of a power outage, as it relied on electricity to work. William Lemichaux was contacted in 1978 by Diane Hartley, an undergraduate student at Princeton that was writing her thesis paper on this building, who had asked how the building would handle quartering winds given the unique shape of the structure. Lemichaux had not taken that point into consideration, as the only testing they had done for wind loads was a testing against perpendicular winds as required by Manhattan's building codes.
The method in which the support beams were oriented compromised the integrity of the structure. This was because the support beams were not oriented in the corners of the building, which usually help protect against quarterly winds. The building was structurally weak against quarterly winds that bisected the building. The maximum approximate quartering wind speed the building could take was approximately 113 km per hour. If hurricane speed winds hit the building at a 45-degree angle, there was the potential for catastrophe. The building could have collapsed under high wind speeds during the time when hurricane came close to the east coast of the United States. In the event of a disaster or power outage, the counterweight would not operate as intended, and a storm that was powerful enough could topple the building. It was discovered that a storm occurs in Manhattan every 55 years that could topple the building with the help of the counterweight. Therefore, there was 1 out of 55 chance that the building would fail in the event of a storm. Without the counterweight, a storm that could occur roughly every 16 years could cause the building to fail. Therefore, there was 1 out of 16 chance of the building failing. During the construction process, the construction company Bethlehem Steel offered the steel supports instead of weld them together as outlined originally. The structural engineer approved of these changes, not knowing that these changes could affect the structural integrity of the building.
Ethical issues. The main ethical issues at Citicorp Tower was surrounding Le Mercier and his company. The first issue was the analysis of the wind loads. Now, Mercier, being the accredited engineer that he was, should have been able to identify that the building was not like regular size skyscrapers, so it had a wonky 3-pillar design. Because of that, the building was not accounting for quarterly winds, just the minimal standards set out by building code, which would have been outdated, which happened to be a violation of section 72.2b, safeguarding of life, 72.2i, which would have been reporting to the public when discovered, to potentially protect or to let the public make their own decision instead of keeping it a secret for 20 years, while at the same time also violating section 77.2.8, the fear of repercussion if the issue were to go public. The possible solutions were to go public with the issue, which would have addressed all of the violations, and then immediately resolving the issue by strengthening the building's joints. The next ethical issue was replacing the welds to bolted connections. This was a violation of section 72.2.a, neglect by the firm by not checking if the bolted connection would have been strong enough to support the building throughout different weather conditions which are commonly happen in Manhattan. And, while not informing Le Mercier of the decision, which by doing so, they also violated section 77.3 by not informing Le Mercier. The firm also violated section 77.1.v, which was making a decision without fully understanding the repercussions of them. This could have been solved by informing Le Mercier when the proposition of changing the welds to the bolts was given, or one of the workers blowing the whistle on it when they would have discovered that such an issue had occurred, which have most likely eliminated the entire issue. In addition, when Le Mesurier was first informed of the change, he could have directed for the immediate reinforcement of the welds, instead of waiting for the completion of the building. However, this solution wouldn't have changed the fact that the firm already had violated the regulations. The final ethical issue occurred was not informing the public of their discoveries of their issue. The public has the right to know what is going on when their lives could have been in great danger, and by Le Mesurier and his company withholding that information, they violated multiple ethical regulations. Le Mesurier and his company never informed the public of their mistake, and when addressed, Le Mesurier downplayed the situation by saying the building was up to code and able to withstand the anticipated wind loads. When addressed about the braces, Le Mesurier declined to tell if the braces were optional. By withholding information from the public, it violated Section 72.2.A, negligence when reporting that his building was structurally sound, violating 72.2.B and 77.2.I by not informing the public of their miscalculation and letting the people work in the surrounding areas risk their lives. While withholding the information, they also violated Section 77.2.A by not maintaining the honor and integrity of a profession out of fear of repercussion, which also delayed the potential integration of this case into engineering regulations and standards, which could have been addressed by having the company outreach to the public and the media, informing of the issues which occurred, and by doing so preventing the risk of damage and harm done to others by evacuating the area and performing immediate repairs, which would have damaged the public image of the company, which by doing so would have put the public first instead of their personal interests.